Hi, hello, welcome back to our channel Chemistry with RK. So I have come up with a multiple choice question which is asked recently in JEE Advanced. Okay, the question is which of the following is aromatic in nature or aromatic compound, and the options we have chrysene, benzene, naphthalene and anthracene. So among these four options they are asking that which of the following is aromatic. So one of the very important points we need to observe when we are defining the aromatic nature of a compound, that must be the compound must follow Huckel's rule, which is actually 4n plus 2 pi electrons. So this is actually called as Huckel's rule. Okay, yes. And then what is this n could be? N value could be 1, 2, 3, and then it can be any number. Okay, so keeping that point in mind, so what exactly, how to apply this formula to the compounds, I'll tell you, don't worry. And then the second rule we need to follow to define aromatic nature is all the central atoms in the compound need to undergo sp2 hybridization. sp2 hybridization. Okay, yes. And then next, the third rule we need to look at, that is the molecule need to be a planarity. The molecule need to follow the rule planarity. And the fourth one is the molecule need to have a conjugation. So what is conjugation actually? Conjugation is possible mostly in most of the cases. Actually, among them generally we see the conjugation possibility in the case of alternate double bonds, double single. In such case we can have a conjugation, or else double single and with a positive charge, or double single with a negative charge. Also, you can also have double and then single with a lone pair. And then even some other conjugation rules are also possible, but mostly we are going to deal with these four in deciding the aromatic nature of the compound. Okay, and now keeping this particular 4 points in mind, let us just go to our options, that is chrysene. They have given the compound chrysene. So what we need to do, the first option we have, let me see, the first option we have, that is chrysene. So what is actually the compound chrysene is? Okay, so chrysene actually have 4 benzene rings fused with each other. Actually, if you look at the benzene structure, we know that it has alternate pi bonds. Yes, where you will have this particular structure, and then yes, if you observe, yeah, this is the structure for what? Chrysene. Okay. So chrysene structure. And now if you observe carefully, how many pi bonds are there in this? Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 pi bonds. So we will have 9 to the 18 pi electrons, right? So each pi bond, generally a bond will have 2 electrons. So particularly pi bond will have 2 pi electrons. So totally 9 pi bonds are there, 18 pi electrons. So this chrysene has 18 pi electrons. And now how to see whether this chrysene follows Huckel's rule or not? Actually, what is the Huckel's rule? So 4n plus 2 pi electrons. So if you substitute any of the whole numbers here in the place of n, please check whether we are going to get 18 pi electrons. So if you substitute in place of n, if you substitute 4, then it is going to come out as 18 pi electrons. 4 for the 16 plus 2. So which mean that chrysene follows Huckel's rule. So first point is done. Okay, chrysene follows Huckel's rule. And then second, that is all the central atoms need to undergo sp2. Yes, if you observe, generally the double bonded carbon is given sp2 hybridization. Yes. Okay, and then all these particular central atoms, if you see all these carbons in the whole molecule, all these carbon atoms are attached to sp2 hybridized carbon. So we can able to say all the central atoms are in sp2 hybridization. And then the third point we need to, so generally the compounds with all sp2 hybridized central atoms generally follows the planarity also. And then the next one, that is the last one, conjugation. So you need to see conjugation, very important. Either you can have any of those 4 conjugation rules, but if you see here, that is double single, everywhere you will see the conjugation, continuous conjugation is there, which mean that chrysene follows all the 4 rules of aromatic nature, which means that chrysene is our answer. At the same time, actually this is a multiple choice question, so answer could be one or more than one. So if you look at the second option, our very important compound, that is benzene. Okay, benzene ka structure hum log ko pata hai. Yes, we have benzene structure, that is, yes. So simply one of the very important and simplest aromatic compound we have, that is benzene. Yes, it follows Huckel's rule. How many pi bonds are there? 3 pi bonds are there. And then if 3 pi bonds are there, 6 pi electrons obviously. So if we substitute in place of n, if we substitute 1, then it is going to give us 6 pi electrons. So which means that benzene follows Huckel's rule. And then the second case is all the central atoms need to undergo sp2 hybridization. Yes, all the 6 are undergoing sp2 hybridization, and the second rule is also satisfied. All the central atoms are undergoing sp2 hybridization. Obviously it follows the plenarity rule. And then the fourth one is continuous conjugation is also there. Simply we can say benzene is also our aromatic compound. Okay, and then next let us just move to the other option, that is the third option we have, that is naphthalene. We have naphthalene. Okay, so naphthalene is also given in the options. So what is actually naphthalene? Yes, we know very well, 2 benzene rings fused with each other. Yes, this is actually the structure of naphthalene, where we are going to have 5 pi bonds, totally 10 pi electrons. If you substitute 2 in place of n, 4 into 2 plus 2, that is 10 pi electrons we are going to get, which means that naphthalene follows Huckel's rule. If you see, all the central atoms are also undergoing sp2 hybridization, and then sp2 hybridization, and then plenarity is also possible, and then conjugation is also there. So this is also our option. And then let us not avoid the fourth option. Let us just check whether our fourth option is also aromatic or not. What is that? Anthracene we have. Anthracene. Okay, so we have anthracene. Just if you look at the structure of anthracene, yes, there are 3 benzene rings fused with each other. Okay, so yes, you will have alternate pi bonds in anthracene. Yes, totally of 7 pi bonds you will see in this, totally of 14 pi electrons. 7 pi bonds, 14 pi electrons. If you take in place of n, if you take 3, then it is 4 3s are 12 plus 2, 14 pi electrons we are going to get. And the second rule is also all the central atoms, not one particular atom, all the central atoms need to undergo sp2 hybridization. Obviously the molecule is said to be planar. And the fourth point, that is conjugation. Yes, the molecule completely have conjugation, which means that anthracene is also our option. So which means that for the given question, all the 4 given options are correct. Okay, so we need to select all the 4 options. Yes, this question is asked in advanced, so please don't avoid this. So all the 4 options are correct for the given question. Thank you so much. So such type of conceptual based within the particular question I am going to discuss the relevant concept. So don't skip my videos. Please, I want your continuous support. Thank you so much for watching the video, and wait for the next video. Thank you. See you soon.